I'm recording this, so if you miss anything, we'll be able to go back and talk about it. But basically, when we try to pick out random things, it's not so random. And so we devise a system. Last time we talked a little bit about how do we outline a system. Something on the AP test might ask you to design an experiment, design a method of sampling. And so basically, we boiled it down to 3 steps, right? And so we got to touch on those 3 steps. So you got to tell me where we're going to start. So start with the first column.
Should we write this stuff down when we if this was a question on a test, or can you number the stuff? So do they have do they have to be like this, or do they have to be like random and then that's all you? Can you go 1, 2, 3?
Yeah. So yes, yeah, you can do that. You would list out the steps. So I'm not necessarily going to number them because I'm giving you the elements that need to be included in there.
But this is what it should look like.
Yes. Okay. Yes. So you need to have these pieces in there. Okay, so you're going to start with the first column. Label the seats 1 through 5. Now this is if you're trying to take one from each vertical column. So label the seats 1 through 5. So you go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, etc. And you go all the way down. Okay. And what's that? Yeah, because yes. Now, understand, what I'm doing in this is I'm saying, do it this way. What I'm going to have you do is pick a way. So I'm not necessarily going to say, pick one out of the vertical column. I'm going to say, pick a way. Well, you need to designate what you're doing. So I said, so start with the first column, label the seats 1 through 5. That's because I'm picking the way of labeling them vertically. So then we're going to, what? All right, so random integer, so you do a random number generator for 1 through 5 to get one number, for one number. And like we talked about, you might say this, rand int 151. Is there another way to do it? Sure. You've got 10 rows, right? So you could do 1, 5, 10. To do it 10 times, it would give you 10 numbers. And you have the one for each row. Okay? So select the seat and repeat with every column.
You don't have to say but you don't have to say in the direction you're going left to right to left. Okay, it's in the book.
That's right here. Repeat with every column.
But when you're labeling it, labeling 1 through 5.
Remember, your book lays it out as if you have nothing. Okay? So I'm combining it with my picture showing what I'm doing. Okay. It just needs to be clear what you're doing.
Okay, so
label every seat in every column. Label first column 1 through 5. Label next column 1 through 5. This is sufficient.
With the picture?
Yes.
But if you didn't have the picture, then what? Is that still labeled?
In every column.
Okay.
Gigi.
So if I get the R and G and down, does it matter how I write the first 2 steps?
As long as you have every seat labeled and it's according to the way that you're supposed to go vertically for this problem. Okay. So which method do you think is best? The first one? Okay. So the first one's the least amount of work. Anybody else have other thoughts?
I think the second one.
Why the second one?
Because it's more accurate. Because people's experience in the first row is probably going to be better.
Okay. Anybody else have the thoughts? Yeah.
What is RNG?
Random number generator.
For number 1.
Random number generator from 1 to 5. So it's going to randomly pick a number between 1 and 5.
Okay.
Gigi, what do you think?
Well, I was just going to say that, I don't know if this is how it goes to be, but method 3 is, the least diverse, I think.
How so?
Well, the way I found, the way we did it, we got, 3 3s in a row, 2 5s in a
that good or bad?
It's not ideal.
Why?
We talked about it last time. I talked about like in the first one, 3 ones in a row. It's just like
So think about how they price seats, right? How do they price seats for like a stadium? Closest to the field costs more. And then so you've got these are the most expensive, these are the most expensive, right? Because they're by the 50-yard line. In general, there's no seat up here, even at the 50-yard line, that even comes close to that first row. Why? People want to be closer. People want to be closer to it. And so in general, the people in this first row are going to have a better time than the people in the last row. The people in the second row are going to have a better time than the people in the last row. How do we use that thinking to select seats? Which of the three methods accounts for that the most? Number 2. It's method 2. Method number 2 says, okay, given that the most significant characteristic is proximity to the stage, let's pick a certain number from the people closest. Okay, now we need to represent the people second closest, and the people third closest, and the people fourth closest, and the people fifth closest. So the rows, because your row affects how much you like the show. That is reflected in seat prices pretty much universally. Okay, I'd like for you to turn to page number 5. I would like for you to run 3 experiments. You are going to do this, run the experiment that you designed for the whole thing, simple random sample, for stratified by row and stratified by column. Okay? I want you to actually do this in your groups. Do it in your groups. Practice using the random number generator. Practice finding those samples. Make your dot plot of your, make your dot plot of what you found. Find your dot plot of your, dot plot you're going to add to the one on the board here. I'm going to put it up in a minute. And you're going to put your samples up in the thing above. Gigi.
well, so like I agree that method 2 is like the most effective.
Yep.
But can someone also argue that like again because like your row affects how much you like the show, but for method 3 it could also like show how much you like the show versus like being in the back.
So let's say you did it by column.
Yeah.
And you got all 5s and you only asked people in the back row. Is that going to give you a good sense of the population? No. Whereas, what if I got everybody from a certain column? What if I got all 5s when I sampled by row?
I would get like
So yeah, they're all in the center, which could be a little bit better, but it's the more significant characteristic is your proximity to the stage, not necessarily your left to right from the stage. But that's a good thought because what is most significant is really the question we have to answer when we're picking our strata. All right, we're going to keep going. So here's what's going to happen. I'm going to predict this for you. When you do a bunch of data, so we only have 11. What's the problem with 11? And honestly, we only have 8. What's the problem with 8? Is this an outlier? Do you know?
Possibly.
It's possible. Okay. With only 8 data values, it's a challenge, right? What does one of these dots represent?
and enjoyment.
An average.
The average of 10.
The average enjoyment of 10 people. So really, on this graph, how many people's enjoyment do we have represented in some way?
90, 80.
Like
I don't know
80.
how many we have.
Right? So it's very dense. So this sampling distribution is a distribution of samples. Well, here's what would happen, and well, what do you think? How would you describe these?
It's
Method 2 is not spread out. What would we say? Like, how do we say spread out in statistics?
Very.
This one has the least variability. And as you would continue to do this with sample after sample after sample, if we had 100 people in AP stats, guess what? It would continue to do this. And that's what a good sample will show you. A good sample will show you if your data is correlated. A good sample as it gets denser, a good sampling distribution as it gets denser, is going to be less and less variable. Okay? So let's keep walking here. Let's talk about yes.
So if you like did this, and like basically through that 80 people are represented, and you keep on doing it to find which is the least variability, isn't that basically the same amount of effort as just asking all of them?
Now, that's a great question. How many people are in the population of this study? 50. So would it be just as easy to ask 50 people? Maybe. However, think about the scale of what we're trying to do here, right? And so this is a simple example to give you something you can grasp onto. But when we start to talk about like population density, or we talk about a sampling distribution of voters, you see how it gets really like there's a lot of people to ask and a lot of things. So if we can hammer out a sampling method that's going to give us a good representation of our population, that's really what we want. So here's the important ideas from this. Number one. A stratified random sample. Okay, a stratified random sample. That's what we did when we did by rows and by columns. A stratified random sample splits population into groups, which are called strata. And chooses an SRS from each strata. Chooses a simple random sample from each strata. So when we said, hey, our stratas are rows, we chose a simple random sample from that row. We're going to juxtapose that with a cluster sample. And a cluster sampling is, it splits the population into groups. Based on location, these are our clusters. And the randomness comes here. They randomly select a cluster and ask everyone. So you're either randomly selecting people from a given group or randomly selecting a group and asking everyone.
Wait, why would you ask everyone?
Here's a great example. All my examples are great. I always think this. So what would give you a better representation of the upper school average age? Here's the two choices. You ready? Right now, a stratified random sample would be for me to do this. Number everybody in the upper school's rooms, 1 to whatever, 15. Randomly select 2 people from every room and ask them their age. Find the average. Okay, that's a stratified random sample, right? My strata are the rooms, and I randomly pick 2 people from each room. A cluster sample would look like this. I wait until family group time, I label every room. I randomly pick 2 rooms and ask everybody in the room. See the difference? So right now, because it's classes, it's roughly by age, right? We have juniors and seniors in here. So randomly picking 2 would give me kind of an upclass. Whereas I go to freshman bio, there's only freshmen in there. So if I randomly selected a cluster, I'd get 20 15-year-olds. Well, that doesn't really help me. I'd get 20 17-year-olds. Good. Well, what about the people in the middle? What about the 16-year-olds? They might not even be represented. But if I do a stratified sample, in every room I pick 2 people from a room, I'm getting kind of an array. Whereas if I wait till family group time when I already have an assortment and I pick 2 random rooms, you see the upside. I don't have to go to every room then, but I'd get a lot of data, but it depends on how people are arranged during those given times. Gigi.
How is based like split into groups based on location? Why is that not the first example you said of classrooms? Because isn't that like locations of the clusters?
The key is ask everyone. That's the key. So this is, yes, they seem relatively, it's like those seem like the same. Well, stratified random sample is go to every strata, ask random people. Cluster is go to random strata, ask every person. Okay. Simple random sample. Choosing a group, this is how important this is, from population. So simple random sample is choosing a group from the population so that every individual and group of individuals has an equal chance of being selected. So choosing a group from a population so that every individual and every group of individuals has an equal chance of being chosen. Not will be chosen, has an equal chance of being chosen. We label. We randomize. We select. Important to label first because as we discussed last time, if I just pick 3 random numbers and then I go back and label you guys with the numbers, it could seem like I was trying to cheat the system. Like, depending on where I number, I could make Antonio number 4. And so if I randomly pick 4, I'm like, let's see, 1, 2, 3, 4. Oh, hey, he got randomly picked. No, you have to label people first. Label the rooms first. Label everyone first. Okay, what I'd love for you to do right now is just check your understanding. This is representative of kind of a free response question. I want to give you about 6 minutes to work on this so that you can kind of get a feel for it. But basically the prompt is a factory runs 24 hours a day, producing wood pencils on 3 8-hour shifts, day, evening, and overnight. In the last stage of manufacturing, the pencils are packaged in boxes of 10 pencils each. Each day, a sample of 300 pencils is selected and inspected for quality. They want you to pick how to do a stratified random sample of 300. So that's this one. I'm going to leave this up here, right? Stratified random sample. So going to every group, picking random things. And also a cluster sample. So going to random clusters, picking every individual from the cluster. And then in number 3, you are explaining the benefit of using the stratified and a benefit of using the cluster. So you're going to have, here's the benefit of doing one, here's the benefit of doing the other. Okay? So think through it with your group for about 6 minutes here. So it's not the same as, and that's frustrating because for so many years math has been like, okay, here's 1. Hey, I changed the coefficient. Yay. Okay, this is different. So I'm actually asking you a couple of different things. So in the last one, it was like rows. Okay, strata by rows. Okay, strata by columns. Well, so what could be strata in this example? The shifts, right? I think that's a good logical choice. And I think your group alluded to it, and other groups did as well. Why is strata as time of day, the shift time, why is that a good strata to evaluate on in this example?
People might be like more tired in the morning or at night.
Quality of pencil could be affected by the time of day you're making it. If you're a daytime worker, great. If you're a middle of the night worker, are they really as good? Are they sleeping in the day? Are they just staying up all day and staying up all night thinking, I'm just making pencils, okay? So that's a great strata, right, to divide on. And so let's just look at the first example, number 1. So let's say this. Describe to me the experiment, and be brave, because I know you're like, I don't know if I want to say it because I'll probably get it. What'd you do? Yeah.
Label pencils in the first 8-hour shift, random number generator of 1, and the total produced during that shift, and then pick 100 from that group. Select the corresponding pencils and repeat per shift.
Perfect. Yes. So for each shift, so it says describe how. So here's what we're doing, right? For each shift, day, evening, night. Choose 100 pencils. That's what we're doing, right? There's 3 strata. We need 300 pencils. So for each shift, we're taking 100 pencils. So number 1.
No, but like they're just pencils. Like they can give them pencils. But in classroom.
Label the pencils 1 to end. Some of you touched on this point. How many pencils do they make during a shift? We don't know. But if we label them all, okay? 2. Randomly choose 100 different. So you pick 100, pick 100 unique numbers. 3. Select those pencils. Repeat for all shifts. Yes?
Do you have to say RNG or can you do the
Random in is fine. Yep, that'll be fine. Now, here's the point. So I think conceptually, we're like, okay, I get that. That makes sense. Strata. Then we switch to clusters and people are like, all right, the 3 clusters are the 3 shifts. So I'm going to take all the pencils from a given shift because that's what he said. He said randomly pick a shift, pick all the pencils. What's the problem with that?
Does not represent it properly.
Evening and night.
Hold on, not about that. So what's the problem with trying to pick 300 pencils and making the shifts the clusters and then taking all the pencils from a given shift when trying to find 300 pencils?
Does not count for the other 2 shifts.
That's not 300 pencils. It doesn't account for the shifts. I don't. So there's okay. So
Oh, so you can't do all.
nah.
No, isn't it?
Cluster sampling. This is the definition of cluster sampling. Assign each cluster a number. Randomly pick enough clusters to get what you want, and then select everybody in the cluster and ask them. Or in this case, examine everyone in the cluster. Randomly pick a cluster, select everyone in the cluster.
Don't you like divide it?
So what's the problem with equating clusters with shift in this case?
Different production. Like there could be like more produced in like the first shift and like the second shift.
yeah, how do I ensure I have 300 pencils? Or like, how does it randomly account for the shifts? So how do we group them? So what are the clusters in this case? The boxes are the clusters. So the question is, how in the world are we supposed to know that? Let me go back to the example that I was pointing out with the ages. There's a bunch of different ways to group students, yeah? So let's say it's family group time, and I say, hey, I want to get an idea of what the age of students are. Here's an option for clusters, right? Every classroom. Oh, Mr. Saris, that makes so much sense. We'll just randomly pick 2 classrooms and ask everybody. What a great idea. But what if somebody was like, I don't really get that. I want to pick my friend group. I'm going to pick my friend group. I'm going to randomly label each friend group. I'm going to label every friend group, and then I'm going to randomly pick 5, and I'm going to sample everybody in that friend group and ask them their age. What's the problem with that?
Why would you do that's too relative? Like, there could be someone that's like, you know,
But when I give you an obvious example like that, you can say, oh, well, don't do that. I mean, the cluster should obviously be the classrooms. For me standing up here, I go, well, it's obvious that the boxes should be clusters. How did I know that? Exposure, experience. And it wouldn't make sense because if I randomly, so how do you know? You don't know yet, now you know. And so how do I apply this to another one? You have to kind of think not necessarily specifically about, okay, this example, although this example should give you an idea that there's different ways to break things down, right? Because in this one we're talking about shifts, we're also talking about boxes of pencils. But the idea is, and I think this is what Vic mentioned, was how are we representing each shift? Or how is every group equally likely to be represented? Those are the kind of things you have to think of. And so, how do we do this? Well, we have to label each box 1 to n. Which boxes? Which shift?
All of them.
All shifts, all boxes. Label each box 1 to n. So now all of a sudden I see that every group is equally likely to be chosen. Number 2, randomly choose how many? I need 300 pencils, so I need 30 boxes. Three, select those boxes. Here's the key. You ready? This is the difference in cluster sampling. I randomly select those boxes. I then examine each pencil in those boxes. That's the difference in cluster sampling. Cluster sampling is randomly picked. I'm sorry. I got this. Sorry, it's a pickle bucket. It's not see-through. I should have got a glass. Okay? So you randomly select the clusters and pick everybody in the cluster, as opposed to randomly picking going to every group and randomly picking from the group. Yes?
So you're saying
If you had to, how would you put this in your calculator if you don't have like an upper, you only have a lower because the upper's in? Like, could you still do the?
Well, so in order to do this, you'd have to have more information. You couldn't actually run this experiment as is.
But you still have to write the formula like in your step.
Yeah. This is huge right here. This is huge to hear. To understand, you have to go 1 to n, tells readers that you're saying all of them. This literally means to all. I don't even want to write that. But it means you're going to the end of the number of pencils, no matter how many there are. Gigi.
So is it correct to write it as RNG 1, n, 30?
Be careful. If you do random integer, yes. Because some random number generators have different Yes.
So if there's like you have to compare like a stratified versus a cluster, it doesn't have to be the same amount of pencils or like the same amount of something. It just has.
Well, think about the rows and columns, right? In our rows, they had 10 seats each. In our columns, they only have 5. From the Timberlake example. Okay, so describe a benefit to using the stratified random sample. What was one benefit of using the stratified random sample? This one here.
Equal representation from
Equal representation from
each shift.
each shift, sure. Do you definitely get something from each shift? In the second one, do you definitely get something from each shift? Not necessarily. But what's one of the benefits of the 300 pencils down here, like doing it as a cluster? My goodness, is it easier to pick out a whole box and look at all those than picking out random pencils, right? Because if I'm numbering the boxes, so much less numbering, okay? And so, there's benefits to both, but your cluster sample is going to take less time. Okay, let's skip over 2 pages. So skip the next page and go to this one. 4.1 day 3. I'm going to give you some notes, and then we're going to go back and do the first page of it. So we're going to talk about what's going on, and then you're going to go back and look at the samples and see what's wrong with them. You've pretty much correctly identified, and I think you can kind of sniff it out, right? You can sniff it out when it's wrong. Like if I design an experiment, you're like, well, that's not right. What about these people? Like when I gave that example of, we asked everybody in San Francisco, or sample people in San Francisco, how they felt about President Trump. Well, you kind of laughed about it, right? Because you're like, oh, they definitely answer one way or another, based on regional politics or whatever. If you ask people how they feel about, anything, you could sniff out bias. Well, there's different kinds of bias. There's different ways that we describe bias. So here's one. This one's called undercoverage. When some members of the population cannot or are less likely to be chosen. Second one is called non-response bias. And that's when an individual is selected, how fun, to be in a sample but chooses not to participate. Or isn't reached. This is different from voluntary response. Voluntary response was like that Parade magazine one where we had We said, where they were talking about cell phone banning, and they said anybody who wanted to could write it or could go to the website and vote. It's different from that. It's me saying, Eric, I'm going to ask you this question. And he's like, nah, I don't want to respond. Vic.
So the one in our book about the supermarket sending like a survey to 1,000 people and only like 100 something returned it, is that non-response or is that?
I want you guys to debate that. We'll talk about that after this. Okay? I want you guys to debate that because there's a subtle difference. That's a good question. We're going to revisit that. And the last one is this, response bias. It's a pattern of inaccurate responses. It could be due to wording, interviewer, lying, etc. Jared, how do you feel about the dress code?
Okay.
You like it? You like wearing a tie?
Okay, it's fine.
Gigi, what do you think? How do you feel about the dress code?
I like it. I don't have to pick my outfit.
How do you feel about the sweater on Chapel Day?
I don't like that.
What if I called everybody in the school into my office? One at a time, I interviewed them about the dress code. Okay? Think about that versus sending out a survey in theology classes where I asked the same question. Which one do you think is going to get a more accurate response?
First one, as a fact.
Well,
The first one?
I
survey,
can't
if
even
you
get your
remain
book quotes, okay?
anonymous, then people will just go in. But
Well-
the first one, like if they're scared of you, no one's gonna tell you that they don't like something.
So let's assume all things are equal. Let's assume that people are actually going to take the survey. They'll actually take it. I mean, they're not going to get their yearbook quoted, but let's assume they're going to take this survey, right? Which one do you think is going to represent people's actual opinion better? About the survey, why?
Because I don't want to hurt your feelings.
They don't want to hurt my feelings. They don't want to.
They have
Well,
the
My
it's
answer.
like
thing,
the
right?
award. No repercussions.
Like, what if I held up my phone? I'm like, hey, is my kid cute? Oh. Or it was like a survey online, like, is this baby cute? No. Right? Okay. So non-response or response bias has to do with the way that you ask the question. This is huge, and so this is why we talk about the types of surveys, the type of studies that we do. Like there's double-blind survey. Like you don't want the interviewer or any factors to. You actually want to get people's real response. And so when you're designing experiments, you have to think, how am I going to get down to what's real? Eliminate lying. Wording is super important. And so if you've ever taken a survey and you're like, why do they keep asking me the same question over and over and over with different words? Well, what they're trying to do is they're trying to eliminate the fact that you didn't understand the question or it was worded in such a way so as to lead. And so in a lot of surveys, it'll be 50 questions long. They're really asking you two things, but they have like 25 questions that are worded similarly, trying to make sure that they eliminate response bias. Okay, here's what I'd like for you to do. Work to the check your understanding right now with your groups. We're going to go over that, and then you're going to do the work on the first page of that sheet. In this example, the sample's chosen at random from a telephone directory. What did you say about that? I agree. Why?
You could not have a phone.
Yeah. So this would be under coverage. So only people with telephone numbers. I don't think I'm in the telephone directory.
Yeah, they still have them.
Okay.
60 plus.
So in the directory, okay, so only people with numbers in the directory could be chosen. What about the second one?
Non-response.
That is non-response. Okay, they were chosen, but they could not be contacted. So they were one of the ones chosen. So they're in the sample, but they could not get their response. What about the last one?
Response. Oh, is that wrong?
What about it is response bias?
Because there's potential that the interviewer could lie.
What if they asked it perfectly?
Is it undercoverage?
They could, well then it wouldn't be that.
This one's tricky. It's not one of the three we just talked about.
Convenient.
This is a convenience sample, okay?
Wait,
That was a trick question.
Yeah,
Oh, that is a convenient sample.
okay. This is a convenience sample because, why? Why is that a convenience sample?
Because it's walking around.
Yeah, they're around. The people walking on that given sidewalk, maybe it's lunchtime outside of a big corporation. They all work for the same company. They all just got off the bus. We don't know. But it's a convenience sample because you're not designating a randomness to it. You're not designing a system at which everybody could equally be chosen. Gigi.
Why? Okay, so we like agreed on convenience, but also like under coverage because if you're only choosing like certain people on the sidewalk, then like doesn't that mean others are
Yeah,
less
the
likely to be
people that
chosen
aren't.
that aren't those people? I feel like I could argue that pretty well.
Like if someone's not walking, they're not going to be chosen, but you don't.
Yes. So several different types of bias could apply in a given situation. And so yes, it's under coverage, but the bigger deal is you didn't design a system for this. Like as you can see when we did that example and you put your data up here on the board, it's kind of inconvenient to design an experiment and execute it. Like it takes a lot of work to randomize people and stuff like that. So if you're ever like, wow, this will be easy, I'll just ask these 5 people here. You're not doing it right. Okay? So yes, I see how you could have an argument for that, but understand that it's also a convenience sample. Yes?
Our convenience sample is just like always wrong.
Unless you've randomly selected, yes. Okay, so let's talk about number 2. You need to be careful with your wording. So a survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Okay? Why is the word opposed particularly inflammatory in this case?
Yeah.
Yeah, it's a double negative. So you gotta be careful.
Yeah.
So you gotta be careful here because it makes it seem like these people would want disposable diapers to be allowed.
Yeah.
Okay?
So they do. They want.
Yeah,
Well,
I
they
just
could
don't
also
know.
read the actual
They could
question.
be like the double negative, like 90% no. But I'll-
You're welcome.
I would love
Like,
that.
like she's in here mid-November.
Okay? So let me ask you this question. Hold on, we're not done yet. So you think the estimate of 84 is less than, greater than, or equal to the percent of all people in the population who would oppose banning disposable diapers? Explain your reasoning.
Greater.
84 is likely greater. The wording of the question makes it sound like diapers are not a problem in landfills. Here's the actual question. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. What does that make you think? It's not a problem. You spend less than 2% of your day doing this. Well, that's not a problem. It's only 2%. I got 98% left. Oh, we got 98% of the landfill left. So you see how that question leads. That question leads you to a given conclusion. Okay, and so the wording is leading or misleading. Okay, it makes you think they're not a problem. It makes you think they're not a problem. Okay, so part of your homework is to do the first page of that. I do want to talk about one more thing, and this is very straightforward. So go to this one, where above the computers.
Wait, what is our homework?
The first page of that. So the 4-point, the one with the meeting with President Obama at the top. The president says, do your homework. That is your homework. That's part of your homework. Part of it. The other part is going to be the first page of this, but I want to talk to you about just a couple other things here. So, we're talking about experiments, and we need to talk about the difference between experiments and observational studies. Okay? What we've been doing so far is talking about observational studies, okay? We are only observing, so there's no treatments. There's no treatments, there's only observations. So there's no one group is doing this, another group is doing this. In an experiment, you're doing something to people. And these are called treatments. The treatments are imposed. So when I ask someone a question, Jack, how do you feel about the dress code? I'm not imposing him on a treatment. There's no treatment. I'm just asking. I'm asking a question. Now, how I design that treatment, how I design that study is important. How I ask the question. How do I divide the groups? How do I pick people? It's important. But I'm not imposing any treatments on them. Because what an experiment does is it allows for causation. Does what I'm doing cause something to happen? The other times I'm merely observing. I'm observing what's happening. Now I can think about causation. Oh, maybe this causes this, but I can't determine. I'm only observing. And so when we have experiments, we start to talk about variables. Explanatory variable. These are the ones that are used to predict. You remember this? And we have our response variables. If we have more than one explanatory variable, we're going to call them factors. What factors? And factors have levels. What were the greatest factors influencing a person's decision? What were the greatest factors that caused whatever it is that we're looking at in this experiment? The response variables, those are the outcomes.
What do you mean factors have?
They're just called factors. So if I said one of the greatest factors in tumor growth in rats was their diet. Well, what was I changing that caused me to be able to look at the tumor growth? I was changing their diet. So therefore it was a factor, it was a variable. Right? So I gave some people, I was watching a documentary this weekend, right? So they fed these rats a diet of 20%, whatever they were measuring. And then the other rats got 5%. And they measured tumor growth in the rats. Well, the explanatory variable, one of the factors was their diet. Well, if they had put another factor in there, like they had said, the temperature at which we kept their cage. Now you have two factors. Does that make sense? So we're kind of use this interchangeably. What was the factor greatest influencing tumor growth? Was it temperature or was it diet? They would ask a question like that. Okay. All right, we're going to pick up there next time. You are responsible for that page. At the top, it says 4.1 day 3. What's wrong with these surveys? What's wrong with these surveys?
Wait, is that the only homework?
That is your only homework. You're gonna have a quiz over 4.1. It's gonna be a group quiz.
Next class.
Okay, group quiz over 4.1. Group quiz over 4.1 next time. Okay?
Okay, we're gonna have my 60.